just their perspectives on what that linkage means. So the way that we're going to handle introductions is I'm just going to open it up to the panel, and whoever chooses to talk first, please introduce yourself, just a brief background, and then you can take it away. So let me start off with the investments to be made in safety and security. And I know that's a broad question, but what is some advice that you can provide to our audience here for determining which one is a priority and which should be the first priority during the design phase of a system or during the commissioning phase of the system? Do you guys have any thoughts around how to make a determination of where the investment should be made and when? Who wants to take that one first?
I can start. Okay. So just as an introduction, I've been with ARC since '93. My background's in process control and process safety, as well as instrumentation and device level networks. I joined the cybersecurity team at ARC 2 years ago with an eye towards taking that experience in process control and process safety and using that knowledge in the cybersecurity domain. And I think it was said earlier that we don't want to distinguish. I don't think we need to distinguish so much between safety and cybersecurity. The two are very fundamentally the same in a lot of different ways. In fact, we first started writing about the convergence of safety and cybersecurity. I think it was back around 2008, maybe sooner than that, when they decided to form a working group 7 between ISA 99 and ISA 84. I think it was around then. Eric probably has a better answer. He knows the exact answer, but it's around then. But even then, they realized that there was some advantage in designing products and systems that were more inherently cyber secure and taking some of the lessons from the world of safety and applying that to cybersecurity. And I think if you look at safety and cybersecurity from the standpoint of the impact of incidents, it's probably pretty close. I read somewhere that the average cost of a cybersecurity incident has doubled this year to, I think, 1.5 million, but that's across the industry. That's commercial and pretty much everybody. We obviously look at the process industries and manufacturing and so forth. One of the things that we look at is the impact of unplanned downtime. And whether it's a cybersecurity incident or a safety incident, that's going to mean unplanned downtime, and it's either going to mean a major plant incident, or it's going to mean your plant shuts down without you really planning on it shutting down. And things like incidents of unplanned downtime can wipe out the profit for a refinery in a single year. One single incident of unplanned downtime can wipe out your refinery's profit. We did a report 2 years ago that estimated that the total cost of unplanned downtime to the process industries worldwide was easily $1 trillion when you add up all the different industries around the world. I don't think that's an unreasonable number at all when you look at all the different industries and the percent of unplanned downtime for those industries. So I think when it comes to back to your original question, as far as like the design phase and things like that, do we prioritize cybersecurity or safety? Well, you prioritize both, right? They're both really intertwined. They should both be looked at as interlocking disciplines, in my opinion, in our company's opinion. Unfortunately, we don't have a lot of ways for you to put that belief into practice, right, as far as actually designing the plant and so forth, or at least I'm not aware of very many practical methods, for which you can do that. And maybe some of the other panelists here can shed some light on that. But my short answer would be they're both incredibly intertwined and should both be looked at, I think, in many ways in the same context. Mm-hmm. So I'll pass the mic down.
Comments? So I'm Mark Duck with Shell Global Solutions, and I've been working in the cybersecurity community almost my entire career with Shell for the last 12 years, and I'm in a position where I work with a team and we build out Shell's standards around industrial cybersecurity, and so it's been it's a fun role, and so we're also within our cybersecurity community within Shell. we're on a journey to understand, also where this intersects with safety. And I think, you say it's intertwined, and do we prioritize one over the other? Well, I agree that it is intertwined, and we can't prioritize, one over the other. They need to be done together. But exactly how are they intertwined? And so when you look at like designing an asset, you have these HSSE risk management processes like HAZOP, HAZOP. There's a whole set of tools they bring to bear on that the result is identifying hazards in top events. And top event meaning that's the release of a hazard like hydrocarbon, toxic substances, energy, and so forth. So you identify all those scenarios, and then you end up picking barriers to manage those top events, getting the frequency of that top event down to a tolerable level. And so where security intersects with that is that some of those barriers, a subset of them, have cybersecurity vulnerabilities, like a pressure relief valve, maybe not, but a collision avoidance radar system, like for an offshore facility. We focus on the SIS a lot, but there's lots of other barriers that they pick, not just SIS, that are taken credit for to manage top events. And so what are we doing in our cybersecurity community to understand, identify those barriers that have been picked in managing the cybersecurity, risk to the integrity of those barriers?
Mark, let me ask you, so as an end user, and if we talk just a moment about safety instrumented systems or functional safety, those types of applications, do you have a preference as an end user whether or not those are separate systems and why, or Eric, converged systems and why? Do you have a particular preference? And we'll get some other perspective on from a vendor as well. So end user perspective on convergence between those two.
Well, I think the convergence is that I think more and more of the barriers that I mentioned that end up being picked in the HSSE, risk management process, more and more of those barriers now have, compute, network, software components, and that brings with the cybersecurity vulnerabilities. So I think the convergence is that's what's unfolding, and then now, by virtue of that, we have to bring to bear on that cybersecurity controls in order to manage. Again, the goal is to manage the integrity or maintain the integrity of those safety barriers, which is, we're trying to keep those top events from happening. Mm-hmm. And so again, I think part of the answer and where the convergence is happening is that we need to have a cybersecurity risk assessment process integrated into the HSSE risk management process. Mm-hmm.
So the components really need to complement the process, not the process complementing the components, right? You want to engineer the system to the process needs.
Yes. Yeah, I think, the barriers that end up being picked, from a safety point of view, I think the cyber, community, like within Shell, doesn't play a necessarily factor in that. But once they're picked, then there's a subset of those that we need to manage from a cybersecurity point of view, because those will have cyber vulnerabilities. And so, and then you need to have your whole cybersecurity program in your industrial space, set up to do that over time, right? Your cybersecurity management program needs to be in place. And of course, we're talking about safety, but there's also your production systems, let's say not related to safety, that you have to manage as well from a cybersecurity point of view.
Mm-hmm. I want to open up the panel for some other thoughts here. Please go ahead.
Thanks a lot. Peter Sieber with HIMA. Talking about my Vita, I guess I last year forgot to celebrate my 30th anniversary of being focused on functional safety in the process industry. So probably you may call me a kind of a hardcore safety guy. Nevertheless, back in 2006 already, I started also focusing on cybersecurity. And from my point of view, the situation is such, first of all, there is no safety without security. I think one of the most important things we should not follow in this perspective is that we may say these are two segregated topics. Because at the end of the day, this is one plant, that is one solution, that is one application we are talking about. And in fact, we have different aspects. One is safety, the other one is security, but we have to make sure that both is aligned. Talking about investment, I get asked quite frequently from customers, but also from other panelists in standard meetings, what are the costs of safety? And my typical answer is, there are no costs of safety. The only thing I know are costs of unsafe situations. And I think we have the same when talking about security. Because at the end of the day, security is a good investment, because the residual costs of unscheduled downtime, of unscheduled incidents are significantly higher than all we can do in terms of the precautions to be taken. Last but not least, when talking about what level of security is good enough, I think it is in fact, like you said, we have to bring it down to the level of the risk management. And if you look at the risk we are covering with functional safety systems, let's say looking at the ZL3 application, what does it mean? Why is it called ZL3? Well, it's called ZL3 because we accept that such a solution may dangerously fail once 1,000 years of operation, right? This is why we call it ZL3. Now, if you're talking about the security challenge for such an application, the security precautions, irrespectively whether it is our organizational measures, technical measures, physical measures, or you name it, need to be good enough that we can say the probability that such a security incident may negatively impair the safety performance of such a solution need to be good enough that the overall solution remains performant to not fail more often than once in 1,000 years, because this is the nature of functional safety, correct?
Wow. Yes, correct.
Lucky me.
I think everybody knows me, Marty Edwards. Most recently served as the director of the Homeland Security ICS CERT program, now at the nonprofit professional society ISA. So, you know, I agree with my colleague, Peter, that, you know, you can no longer separate security from safety, and I would say cybersecurity specifically. If you look at the functional safety or the safety envelope, it occurred to me when Peter was talking that it's almost somewhat of a supply chain problem, right? So if you go into the design stages of the safety logic or the construction of the logic solver, you know, you have to go further and further and further back in your analysis of what are the cybersecurity risks that those steps can have, right? So, you know, what you get into country of origin kind of discussions, and who has touched the logic solver since it was, you know, chips in tubes getting put on circuit boards. And I don't think that we've even come to terms with having the basic process control system and the SIS, you know, in similar platforms, and never mind having the thoughtfulness to start thinking about, you know, where do they all come from? Where does all the engineering for those components come from? And can anybody who wants to do us malicious harm or intent at any step in that process gain access? So I think that supports the concept of you can no longer separate the two concepts.
All right, so let me lay this scenario out for you. Some critical infrastructure actually doesn't much matter. Let's just say it's not nuclear, just so we're not too crazy here. But it's a mission critical application, and an organization that has evaluated the risk in a broad sense to the system, to the control system that runs this operation. And they believe that they have found this balance, this wonderful balance between safety and security. And now it's Sunday at 2 o'clock in the morning, and something breaks. May or may not be a malicious, you know, threat that has caused this situation in the system. And this company, whoever is on staff that evening or early morning, is now tasked with trying to address this situation. And the first thing that they run into is not a safety challenge. It may be that security challenge. I can't get into this system because somebody took the sticky note off the screen with the password or some other scenario. Is that a reality today? Is that a path that we're on as we seek a balance for safety and security in industry? Anybody want to tackle, provide some perspective around
Larry's
that?
reaching for
2
the-
a.m. on a Sunday.
I will mention the link between physical security and process safety, right? Or physical safety, or however you want to characterize it. Because you mentioned the password on a sticky note on the screen,
The
right?
walls are not effective.
What's that?
Walls are not effective.
Yeah, walls are not effective. Well, doors are not effective if they're not locked. You know, control cabinets aren't effective if they're left open. Programming key switches aren't effective if they're left in program mode, while the safety system is running, as I'm pretty sure was the case in the TRITON TRISIS incident. So there is, to me, a lot of basic kind of belt and suspenders, physical, procedural elements that get neglected in plants that leave pretty wide open security holes that are exclusive of what we might find in the system, or more sophisticated cybersecurity vulnerabilities, right? I mean, it doesn't matter how much cybersecurity you have installed or how sophisticated your safety system is. If you leave the cabinets unlocked, in the key switch in program mode, then you're asking for it, right? And that's not to say that these people in the plants are bad people. I mean, this is an endemic problem throughout plants. I think many of the plants, at least in North America, have a lot of these procedural and work process issues that they need to work through. So there's that aspect of it. As far as being able to discern whether it's a cybersecurity issue, or a safety issue, again, I think the bottom line is, well, what you're concerned about is safe plant operation. But it could be an issue if your people aren't trained up on cybersecurity, if they don't know how to identify cybersecurity issues, if you don't have solutions in place that might be able to identify a breach or an anomaly, or something is wrong with the system. Last night we were even talking about operators, right? I mean, how well is the average operator trained on cybersecurity issues? And if there were to be some kind of a cybersecurity related thing that might pop up, that might possibly be visible to an operator, would they even know how to detect it? So a lot of this, I think what you're talking about, speaks to a lot of basic training, procedures, education of the existing workforce, things like that. That's...
Greg, I'm going to ask you. So Maritime Industry, what happens at 8 o'clock in the morning on Monday if they ran into a security challenge to just get a system up and running at 2 a.m. on a Sunday?
Yeah, I guess the difference for me, spending the last 14 years strictly in the maritime industry, I was a chief electrician on a ship. So if you would ideally take your plants or systems and put them on a floating island, the risk for me becomes even greater, because that's not only my workplace, but that's where I live. So for me, it's been a passion to increase the security of those ships, because once I stop working at 6 p.m. in the evening, I'm there until 6 a.m. the next morning, still on the same ship for the next 30 to 60 days. So the last thing that we want are issues, security, especially security related, that could affect that, not only the vessel itself, but the entire crew on that vessel. The last thing I want to do is wake up on the bottom of 12,000 feet of water it's still in my bunk. So yeah, I mean, it's a huge issue for the maritime sector.
Is
Not
a
only
result
from an operational standpoint, but just that safety standpoint.
is a result from some frustration of trying to get a system back online? Just tear that stuff out, get that out of there. Our priority is to keep this system running at all costs, and security just got in the way. Get that out.
It's been a battle, to say the least, to get that buy-in of the implementing the security pieces into those systems. Another large issue, again, is outside resources that have access into those systems for support. from the vendors. So again, getting a control over who's got access into what, and having the ability to understand who's in there, when they're in there, and what they're doing. Again, it's a difficult scenario, but for me, it became a passion of mine only because I lived there. So if you take all those problems and add them into your home and your family, then it really steps it up a lot.
I can comment on that as well. I think you mentioned the scenario where maybe there's a computer down, you got to get it back up, right? Sunday afternoon, whatever. And we mentioned operators. And so I know within Shell, there's a lot of focus on keeping the operators, giving them the right information and let them do their job in terms of running the plant, right? So they wouldn't necessarily get involved in a scenario like that, right? So there's at all of our assets, there's usually support, cybersecurity / system administration, network support. And that team would be the ones responsible for taking care of that. And if there's an incident, then there's an incident management process that kind of kicks in to start the process of not only if it's cyber related, then what do? Do you take it offline so you can do some forensics or whatever? And so there's a team that takes care of that while the operator is doing his job. But one of the other things that we're thinking about, with all the the types of systems that are showing up in the automation solution, general purpose computing equipment, software, network, et cetera, what does the engineer of the future look like? The automation engineer of the future. They're going to need some of these skills, and so I think on a IoT, digitalization, all that, 20 years from now, what kind of skill sets will be needed, by the engineering staff? That's a good question.
So I grabbed the mic too and pulled it over. If you go back to the origin of your question, or the first thing you asked was, if you have something happen at 2 a.m. and there's the password written on the sticky note, I would suggest that if the design of the safety system should be such that it doesn't require some sort of human intervention to perform the safe shutdown function, right? So if you've done your job right, it should fail safe in all situations. Another comment that I'd like to kind of throw out there just for interest is I keep hearing reference to the key switch, right? The program run key switch, which if you go back to the TRITON TRISIS incident was one of the findings, right? That, hey, we left the key switch in the program or remote mode so that we could change the logic in the logic solver without having to send somebody out into a potentially dangerous environment to move the switches, et cetera. There was research performed on some platforms, vendor agnostic research, right? You do know that all those switches are read by a CPU, right? And if all of those switches are read by a CPU and an attacker already has presence on that CPU, they can modify what the system thinks the key switch is in, regardless of the position of the key switch in the first place. So a little bit of kind of food for thought there. Right? And maybe Peter will say that's not true. So this is a good conversation.
Yeah. And some of the more modern SISs don't even have the key switch.
First of all, thank you for voluntarily handing over the mic to me. Probably I would like to step a little bit back with this 2 a.m. Incident, because I think at the end of the day, we need to talk about overall safe operation. The overall safe operation of a plant is much more than just the safety system performing a shutdown when a shutdown is required. Because what really is key to maintain the plant in a safe condition and to maintain it in such a way that it makes money, because at the end of the day, this is what we're aiming for. Now, let me share with you a practical experience I made a little while ago. There was an incident triggered a safety system, and it was in fact not on Sunday morning but on Saturday morning, 2 a.m. and the maintenance people of the customer tried to analyze and to understand what's the situation. So they switched on the maintenance station. Watch up. These people had switched off the maintenance station while the plant is in regular operations, because typically you don't need it. So why should you have it online all the time? So they switched it on, and unfortunately, the PC did not boot. Bad luck. So what they did is, they got another PC, they got their backup data, installed the backup data on the other PC, that worked. They brought the other PC up to speed and analyzed the problem. So far, so good. Well-organized customer. Unfortunately, this other PC was a notebook having UMTS module with an activated SIM card in it. So all of a sudden, the safety system, or the engineering station of the safety system, had a direct connection to the internet, right? And this, I guess, is one of the last things you want to happen typically, right? But from my point of view, it's an example that perfectly illustrates how far you have to think when designing this kind of procedures, when think about recovery processes, and when thinking about what it takes to be able to master all kind of curious situations that may occur during operation of the plant. Because I think another aspect we need to think about is that whatever we install is not required to be operable after installation till the warranty period is over, but typically is operated for 5, 10, or even more years, and is exposed to maintenance intervals in 2, 3, or probably 5 years only. So from this point of view, looking at the security practices we see in the area of IT and also partly in OT, the differences between functional safety and the regular data processing are quite remarkable, right?
I mean, that's a real important consideration, isn't it? That for the business enterprise, the decision-making process that goes into how to address risk, it just doesn't have to consider potential loss of life or physical destruction. That's not a typical event in a business enterprise decision-making process. How mature do you think the process is, and how much further does it need to get in the OT space for us to truly appreciate the actions that we take and the consequences that it might have on a safety system? Do we know enough that, or are we spending enough time at vetting patches and product upgrades and new feature introductions to make sure that it's not having some ill effect on the safety of the system? Will SIL rating save us?
I'm not going to touch what will SIL rating save us, but I will comment on, on the, you talk about patch interval, or you talk about, are we ready? And I would say that from a business process standpoint, we're not ready enough. So in those scenarios or tabletops or business continuity exercises, I don't think we're asking the right questions all the time. And so, expounding on Peter's example a little bit, if as a finding, they found that in reconstructing the maintenance station, they inadvertently used a laptop or notebook computer that had cellular, access, right, that bridged these two networks inadvertently. That's becomes a finding that we should start to question, right? And I would say that the very first time that you are testing out your business continuity procedure or your disaster recovery plan shouldn't be in the actual disaster, right? You should test it beforehand. So we talk about all these incident response plans and all this kind of stuff. It's great having a full set of playbooks and incident response plans to do cyber incident response. But the first time that your people actually pull out the book and do it shouldn't be in the actual disaster, right? So in parallel with that, from a previous session this morning, people were talking about the fact that, we can't patch because maybe our turnaround is 2 years, right? If your system is important enough to have a protection system on it, or is important enough to have all this automation, it's also important enough to have a complete redundant, development environment or test environment to perform, regression testing and things like that on these patches, right? I mean, so we should be able to test all of these things in our business continuity environments beforehand in some reasonable facsimile to digital twin type of environment to prove them out before we actually really need to use them, right? This is fun.
Yeah, I'm actually having a lot of fun. And please let me try to add some more fun to it. Because listening to what you just said, I would like to raise the question, are we really on the right track if we accepting that our technical systems need to be patched once a week, once a month? From my point of view, I think this continuous patching of the systems, all of us accepted, meanwhile, more or less, in one way or the other, is just a path to handle inherent vulnerabilities. Because we are patching our notebooks, our personal computers, our OT systems in order to get rid of inherent risks that got identified and that requiring actions. Now, if you're talking about a safety system, if there is a safety system that required to be patches or being patched once a month or even once a quarter, I would like to raise the question whether in this case we're really talking about a safety system. Because from my point of view, a safety system should be resilient enough, not required to be patched every now and then. What we do is, our objective is that it is key to cover the maintenance intervals of our customers without having the requirement to patch the online systems. And as far as I'm concerned, this is what we can do today already. This requires some more effort than regular IT or OT, but on the other hand side, safety systems are a little bit a special thing.
Yeah, I'm going to just interject real quick, Marty, to Peter's comments here.
Good, yeah.
We've spent a lot of time today talking about patching, and it is easy to lose sight that, there's other ways to remediate risk. And it is entirely acceptable to have other controls that are put in place or relying on controls that are already there to buy time. And sometimes the time that you're buying is not measured in days or weeks. It might be the life of the system because you have adequately reduced risk to what is acceptable. I think that's an important point. And the pluses and minuses of patching as they're discussed between functional safety engineers and security professionals and IT and OT sometimes misses that point of really bringing a balance to other remediation strategies as opposed to just applying a patch. So just some commentary.
Yeah, I agree. And I perhaps went down an inadvertent rabbit hole with the patching comment, but I think you have to make a judgment call about what level of technology or reprogrammable technology, patchable, I guess technology would be another way to look at it, that you use at that protection layer, right? And so the closer you are to, the pretty little clouds in your example earlier.
Bob Ross.
Yeah, Bob Ross. Yeah, the more, I guess, acceptable fast patching cycle kind of thing is. But when you get closer to the protection layers, that gets longer and longer and longer and longer, right? And so, in those kinds of cases, there's probably good use cases for non-programmable through software logic solver applications, right? Solid state hardwired logic kind of thing. And that's kind of some of the concepts around the CCE environment, right? Where purpose-built, purpose-designed systems, right? They exist in other industries where they build specific hardware to act as the protection layer. Maybe we need to think about that.
Let me.
We do this for the process industry as well, and I can guarantee to you that these KISS systems don't need to be patched. On the other hand side, I guess we have to be a bit careful because at the end of the day, we also need to keep in mind that the programmable safety systems have quite a bunch of advantages because I would call it the static safety is one aspect. But if you're looking at entire applications, it's also important that the operators have a clear understanding what's going on in the plant. We need to have things like alarm management. We have to we need to maintain things like performance monitoring and all this kind of things. And if we now say, we have to do all this hardware, this is a little bit like if you're building a house and you're afraid of burglars, you may decide to say, okay, the safest house has no windows and no doors, because then the risk of getting exposed to burglary goes down drastically. On the other hand side, we may discuss the question how attractive it is to live in a house without windows and doors, right?
Yeah, so I'll make a comment. So I'm involved in this open group OPAF initiative, and so I've raised, we have some requirements in there about, we've got to solve this patching problem, right? We are not, in the future, I know we've got to live with our systems we have today, and we have patching problems. But if we're building a new system, then we need to eliminate the patching problem. There's technology that can eliminate, that you should be able to, once it's tested and proved that it's going to work, roll the patch out, online, that you can do that. And so in the future, 30, 50 years from now, we shouldn't have a patching problem. We should keep our software up to date. The other point is that, out of all the cybersecurity risk, where are most of the vulnerabilities? Numbers I've heard is 80% of the vulnerabilities are in our software. And so I think patching is, keeping the software up to date is an important aspect. But to your point, how critical is it with our current systems? And it really boils down to your risk assessment. Right? Not all assets are the same. We have this huge range of assets within Shell, and some of which, unmanned, well pad. I'm hearing from some folks saying we don't have any HSSE risk there. So, we don't put the effort into managing that as we would an offshore floating facility, which is your point about you have people living on that thing 24/7. And so you have to take a risk-based approach to that scenario. The other thing we need to think about as well is that, and this is just keeping a sort of a grounded perspective from a cybersecurity community point of view, not trying to diminish the role of our cybersecurity controls, but in terms of safety systems, they are extremely robust, right? So we talk about SIS, and that's what you use to implement your safety instrumented functions, and that's one barrier, out of a set of barriers that are typically used, right? So even if your SIF is disabled for some reason, and then some initiating event occurs, creating the chain reaction, in theory you have other barriers there. But if any of those barriers are disabled, then your risk, your company probably has a tolerability, a risk tolerability criteria table that says you got to keep the frequencies of these events down, to a very low level, once in 100,000 years or something, and it varies by the severity. But the reason we don't see as many explosions as you would think is that there's all these barriers in place, only some of which have cybersecurity vulnerabilities, and so not patching, maybe that's dealing with one of those barriers, but you have all these other barriers in place. But again, not to diminish the need to manage the cybersecurity risk to our barriers. Yeah.
Greg, I'm going to ask you a question here. Key attack vector we hear about all the time is the phishing email that somebody clicks on, steals credentials. Maybe it's the business enterprise credentials that just happen to be the same creds that are used for the OT environment to allow, the adversary to pivot through that system. So knowing that that is quite typical attack path, to basically become the trusted insider, when we think about engineering systems and we think about that control function and the safety function, and start to determine where do we have the interchange of information so they can be coordinated, where do we collapse them or where do we separate them? Is that an active dialogue today for many companies to think about the attack path and become the active defender, something called active defense, if you will, to understand how the adversary is attacking a system and to design anticipating that and work around that. So is that an active part of the dialogue today in the systems that are being engineered to just recognize where the risk is and to put countermeasures in place proactively?
Yes, I mean, there's obviously in the maritime industry, just a pile of legacy systems that are out there that really have no network segregation between the business networks and any OT systems that they've added into those over the last 5 to 10 years. But from the new build standpoint for vessels, a lot of that is being baked in on the front end now. A lot of the shipyards would prefer not to have to offer that as an implementation, as an add-on. Again, it drives the cost obviously up on the vessels. So they would prefer just to keep them simple and flat network, and here you go. You solve it after you get it. But yeah, we've seen a lot of planning going in on the front end finally to say, hey, we're not going to accept a vessel that has a single network on it, that we want segregation between all these systems.
So what's pushing industry in that direction? Is it regulation? Is it risk that a company just doesn't want to assume the risks that had traditionally been transferred that way because the can just got kicked down the street?
The risk piece plays into it, but I think again, just the modernization of the systems has really grown exponentially in the last few years, where vessel owners are realizing that they can't put all these things on a single network and have it reliably function and safely function. So,
okay. I do want to open the floor up to some questions. I have a microphone. I'm willing to walk around and get some thoughts from you. Tell you what, as I come down here, I've left this slide up here, and Marty, I'm going to ask you. Can you see the slide?
Yeah,
It's big red button. Big red button.
The big red button, yeah, we
Big
had
red
this
button.
discussion.
easy,
So
but
I'll come down to pick up a few questions here, but Marty, maybe get us started on your thoughts of taking us, of not losing sight that in the past there was a simpler time, and that simpler time maybe is something that we shouldn't necessarily lose in our future view here.
Yeah. So thanks, Doug. The premise behind my series of talks on the big red button over the past several years were really as a thought experiment, I guess, to get people thinking about the fact that we tend to over apply technology. And then I guess what I mean by that is we're so used to having everything on our phone or mobile device all the time. We basically think that we can solve every problem by throwing more smart stuff at it, right? So you see a smart grid, smart city, smart car, smart phone, smart home. Whereas I think that we've even touched on it a little bit today, when you're talking about the safety function or the protection system environment, there's a lot to be said for simplicity. Right? So don't overutilize too much technology. I'm old enough to remember that when we first started to do programming experiments on microcontrollers, we used to hand compile assembly language, right? And we used to have competitions for how many bytes can you, get this function to execute with. And now I watch programmers, and I've got a number of college age kids and stuff going through programming language courses and stuff, and they'll take an entire library off the shelf and stuff it into their application to use one single function in that library. Well, okay, if that library has 1,000 functions in it and you're using one of them, that other 999 functions that are there is a pretty broad attack surface, right? That there may be undocumented features in. So if you can boil, the technology that you're using to solve a protection or a safety problem into the simplest platform, usually that comes with higher reliability, right? Less mean time between failures, things like that, so that it's more robust, right? And that's That's basically my key point, is that we have to get away from, as humanity, just wanting everything to have every function and have all these different functions in it, when what we really want to do is make it simple again, right?
Full disclosure, Marty actually owns stock in a company that sells exclusively big red buttons. Just want you to know that. Okay?
Well, my only problem with the big red button is that it requires a human to smash the big red button. Humans don't always smash the big red button in time or at all. And I've heard anecdotes in the industry, and one of them that I have heard over the years was on Deepwater Horizon, where there in fact was a manual emergency system that required somebody to smash a button. But when they saw that the entire thing was lit up like a Christmas tree, they just looked at it and said, that can't be right. And they didn't smash the button in time. So I agree with what you're saying about simplicity. I agree 100%. But I don't know if that should be a rallying cry to go back to manual
You can have automated
human
simplicity.
intervention safety systems. Yeah. So maybe in a literal sense, the big red button's not a great idea. The other thing I wanted to make a comment on was what Greg said about the legacy and legacy systems too, before I lose my train of thought on that, because I don't think we're just talking about safety systems here that are a problem. That there's lots of other, and I've heard them referred to as undocumented devices or undocumented systems. And they include things like terminal automation systems, maybe fire and gas detection systems. There are other systems out there which, if you reprogram them without anybody knowing you've reprogrammed them, will not prevent, a planned incident. So we have to consider those other systems too. So it's not, and that's why I wanted to make this a safety discussion and not just a safety system discussion, although safety systems are probably the biggest and most important aspect of this, but there is a slew of other systems out there that many times nobody pays attention to or realizes, how old these systems are and how vulnerable
I'll just give you one
they
example of
might
that.
be.
One example of that, it's a recovery barrier, but it's fire water pumps. And so, if a event were to happen, top event, then you depend upon your fire water pumps to manage the severity of that event, the fire, for example. And so I know from experience that fire water pumps are typically, PLC driven, on the network, have HMIs. They're not assists, right? So are we paying attention to those kind of systems?
All right, so let's go ahead and shift gears to some of the questions here. Who has questions? Start with you.
Hi, so as reasonable people who are concerned about safety, when we talk about intrusions or attacks on safety systems, we normally go to one scenario, which is the safety system is being disabled to cause harm to the system or to a person. But let's flip that on the head. As these systems become more interconnected and more complex, there's another attack vector, which is we abuse the safety system to shut down the system. So instead of an adversary shutting down the system in order to cause damage through some other mechanism, simply triggering the safety system to cause damage to the system through a sudden shutdown, et cetera, et cetera. What do you guys think about that, to all the panelists? What do you think about that scenario? And are we building these systems to become so digital and so complex that that's going to become a viable attack vector?
Yeah, so I think, if I understand your question right, it's kind of like a denial of service attack, right? So the adversary is intentionally abusing the shutdown system to make it such that you don't run very often. I can tell you that during my years in the field, startup experience, there were many times where we couldn't get the plant started because we had too many interlocks on top of interlocks on top of interlocks that there was no actual way to get it going because it kept wanting to shut itself down. And you only find some of those kind of race conditions, I guess, through testing. So yes, I think that is a valid concern, right? And but overall, we have to put enough robustness into the end designs to be able to hopefully detect and inline prevent those kinds of attacks from occurring. Peter?
Yeah, I think this is a question that directly leads us to the simplicity principle, as I would call it, right? I agree. We see safety systems that are more and more complex, and there are, of course, applications where having a complex safety system is beneficial and is required. But I think it's also important that we narrow safety down to what safety requires to be covering. And when I was young, we had something we called the KISS approach. KISS stands for keep it simple, stupid. And I think today's designers of applications probably would do good and once in a while even spend some moments to think about the KISS principle.
Yeah, I have a question. If you learned, gentlemen, do you think that there's too much emphasis today on not the control system and too much on IT? Because when I look at system availability myself over the last 40 years, you know, I always look at level 1 and 2 and look at the sensor environment. And I sometimes think that we are looking at the wrong kind of convergence. And we should be looking at the engineering side of the house, as Marty kind of alluded to. I think that's what you were alluding to. How do you feel about that? I mean, is that, if you look at the tools that are available for cybersecurity today in OT, I've heard people say they are complex. They're probably good for scaling. I mean, but do they really solve the problem at every layer? If that question makes sense to you.
I'll give it a shot anyway. So, you know, I think perhaps you're getting at the concept that you know, you through some of this added complexity, you know, can, in the IT space anyway, you know, you have this concept, you get too much complexity, adds to the downtime perhaps. But I can tell you that one thing that we often overlook in the sort of OT security space is that there are very high availability IT implementations that exist that have uptime requirements that are similar to SIL type requirements, right? You know, you look at massive multinational credit card processing or bank transaction or stock market, you know, kind of processing systems. They design in a lot of redundancy and a lot of capacity and capability so that they don't miss a single transaction in, you know, billions and trillions of transactions. So I think we could learn some from those industries. And yeah, and so I'll just leave it at that. But.
I think, in fact, you're right. We can learn from this industry being focused on automation, but I think what is important is that we drive a vice versa learning process here, because I think the people from the IT space also can learn a lot from us. Because, for instance, our systems probably may not be required to do trillions and trillions of transactions, but when controlling, let's say, a 750 megawatt steam turbine, you have to have a control algorithm that is executed once every 30 milliseconds, and it has to be performed every 30 milliseconds. And this for years and years and years of operation, right? And this, again, may look pretty much simpler than having such a huge ERP system, but the time criticality is a particular challenge on its own. And what I'm afraid of a little bit is that these kind of aspects tend to be forgotten by the people having a stringent IT background here.
Yeah, I would say, and like I alluded to earlier, that, you know, what does the engineer of the future look like? And so, you know, I don't think we have the answer yet, but there's clearly more and more IT technology showing up in the automation solutions. And so, you know, you still have to make money, you have to manage that equipment efficiently, and so bringing some of the IT ways of working into the environment is probably inevitable, but you can't apply those ways of working. There's constraints on that, right? You know, it's a different environment. We're not managing information, you know, we're managing equipment and processes, physical things. And so, that's a challenge before us. I mean, we're dealing with, you know, all this influx of technology. You know, our engineers need to be trained, knowing things about. You know, I was reading about, you know, time-sensitive networking and how that engineers in the future will need to understand, the latencies over networks and how that works with the process, the 30 milliseconds that Peter mentioned and so forth. And so all that's going to be intertwined in engineering, both a DCS and the related safety systems.
I think if we can put this forward, at the end of the day, what is the outcome is that you may think about concepts like described in IEC 62443, dealing with zones and conduits, where you may say, okay, an overall application may need to consist of different zones. For each of the different zones, you may have different regulations, rules, and practices in order to maintain security. So from this point of view, I guess the baseline for a secure future is there. The key question just is, how can we really establish this? Because, for instance, the newborn business models such as IoT or Industry 4.0 may bring this into let's say on a little bit of a different track, if not properly controlled. But I think even for that, are strategies feasible, allowing you to do an appropriate Industry 4.0 installation while maintaining adequate security. But it has to be done.
Thanks for opportunity to ask a question. It's Michael Clark. I've got a question for Peter and for Mark specifically. Some of us have the opportunity to have an influence in the Open Process Automation Forum. Many of us have looked at today's control systems, and Peter, I appreciated your little quip about having some fun here. Let's have some more fun.
Okay.
Let's ask this question. If you are in a position to influence the outcome of the hardware and software that could be proposed in this new control schema, where is the headspace around the concept of secure by design? Where is that being championed, I suppose, is the question. I'll leave it for you to discuss.
Didn't you talk about having more fun? Well, from my point of view, in fact, security by design is a particular challenge. Looking at our experience, looking how we trying to prevent too much fun at our own development, what we do is that we have a structured design process, that is based on the utilization of clearly specified software modules. We typically do not purchase commercial off the shelf, but entirely specifying and developing our own. Plus, what we do is we do a complete specification of the software functionality, and we do a test, a 100% test against these design specification. And I think one of the weak points that we need to critically think about is whether quality methods and quality strategies for the development of embedded software that are relying on statistical quality measures really are sufficient and should be followed in the future, especially when talking about highly integrated solutions such as the Open Automation Forum at the end will be ending up with.
Wow, fun. So one of the challenges, and I'll take kind of purpose-built safety instrumented systems or protection systems kind of off the table for this comment. One of the biggest challenges or impediments that I think I've seen over the years to the secure by design, Dale Peterson's mantra, right? Is the fact that we as a community build equipment, so a controller, a PLC, and it's used in such a wide variety of applications that you can have incredibly different consequence actions come out of those different applications, right? So you could have the same PLC that's being used in a complex burner management, or in the pulp and paper industry, a black liquor recovery boiler shutdown type application that, there are safety implications if the wrong things happen in the wrong order. And the same PLC could be used in a fairly benign, non-safety critical, application. And so we get this consistent argument that if I build the PLC to have all of the security and all of the reliability and everything on this really highly critical application, it's now cost prohibitive in the lower, the lower class application. So I think that perhaps we've got into this sort of too broad of a one size fits all type thing, and we have to start looking at properly applying even I don't know if we have to have some sort of grade, so you have the cheapo throwaway PLC stuff, and we start to see those, right? There's like a 1-800, a website you can go and buy like a $30 or $40 PLC versus the bigger, more expensive versions. Yeah. So I think that's one of the issues we see with Secure by Design. I think the other thing that you see, and it's the sort of patching thing, right? My iPhone now, the applications that are on it, the apps that are on it, basically update themselves, right? I don't do anything to it. It just says such and such an application is updating. And that's, as consumers, we've kind of got to this place where we're allowing companies to do development on our production systems, right? So they're rolling out new features and testing those new features and tweaking those new features as we use the devices. Well, that's okay for certain commercial or consumer applications. I would postulate that's not okay if you're doing a safety system implementation, right?
Well, another area where I'm also on the smart cities team at ARC in addition to cybersecurity. And a lot of the stuff I see in the smart city sector just downright scares me. It's the opposite of secure by design, right? You see stuff literally built on Raspberry Pi, things of that nature. So it's a wide spectrum of stuff. I think the further you move up into the process industries and things that are purpose-built for heavy process applications like refining and petrochemical are definitely better than a lot of the other things that we're seeing. But it's disturbing to me that we do have this whole new class of product, some of which may not be exclusive to urban environments, but might find their way into industrial environments as well, right? Outdoor lighting control systems, things of that nature that could provide a vector, into a plant. We always pick on HVAC systems, right? Or climate control systems that, there's a few case studies, over the years where those have been easily hacked into and exploited to get to the industrial control system or other functions in a facility or plant. So I just want to say it's a bigger problem than just heavy industry.
Can I come?
I want to make a comment here about secure by design. What does that really mean when we actually we can identify what good security capabilities are in a device. We can even test that. But in this multi-vendor world that we're living in, every device that you pull out of a box has a different configuration. And these are very active dialogues that happen at product manufacturing companies as to what are the defaults that we should have for out of the box. Should all the ports be open or should they be closed? Should we be accommodating the individual that wants to quickly commission the system as soon as possible and then go and harden the system later? Or should we put barriers in place by default that encourage them to utilize security capabilities? And so all the investment that goes into security by design, and if you talk to any of the product manufacturers, they'll tell you the level of investment that they're making. But they may ask you to help them with this big question mark, which is, who are we going to serve and when with those default configurations out of the box? Because that is actually leaving a tremendous amount of risk or introducing risk because there isn't a standardization on what out of the box means.
Yeah, so We talked about this a lot in the OPAF meetings. I'm sitting on the security subcommittee. And so there was an initial term that was used called inherent security. Okay, I didn't like that term. What does that mean, inherent security? But secure by design, the approach that we're on the path to take is that using, for example, the 62443 Part 4-2, which talks about security component level security capabilities, and they're organized into security levels. So if you're using the capabilities that are at security level 1, well, that's that, you know, the $30 PLC. If you're using all the security requirements, you're at security level 4, and that's going to be an expensive, you know, piece of equipment. So the idea with OPAF is that, you know, the market will figure out. I think in this version 1 of the spec that came out recently, the default is security level 2. And so that would be what's tested to be OPAF compliant, is if you have those capabilities built into the component. But we can't forget, secure by design means that, you know, you're using that component in an overall system. So you can't you know, design the overall system without, you know, typically an integrator. And so these integrators need to be skilled in building, or, you know, in secure by design, you know, concepts, right? It's a system that's secure, not the component. The component contributes to the overall security, but the entire system has to be secure. In fact, there's another part in the 62443 series that talks about system level security requirements as well. But yeah, it's a whole process. It's not easy. It's not just, it doesn't just boil down to the defaults, right? So,
I think, and try to get back a little bit to the funny
business.
the funny business, yes. From my point of view, it's a little bit like if you look at the car industry, right? You can make the car or the cars as secure and as safe as you want. If you have idiotic drivers, this will not help. And I think we have a little bit the same, because what do? Well, we teach the drivers, right? And at the end of the day, it's the appropriate combination of both well-trained drivers and safety-capable cars, making traffic safe. And I think talking about security, talking about the correlation between security and safety, we have exactly the same. There's definitely a dedicated set of capabilities that a reasonable product should have, but we also need to make sure that the people who are utilizing the product during the integration as well as during the operation phase of the life cycles know what they do and have an idea of what the consequences of certain decisions may be. And at the end of the day, I think this brings us back to where we started from. Safety as well as security are processes that have technical aspects, but to a big ratio, also dominated by the influences of humans. But at the end of the day, we need to look at both, having the humans appropriately trained and having the products designed and developed with a reasonable set of features so that the humans can use them in a safe and secure way.
All right, so you'll all have a great opportunity to socialize with all the wisdom here up on stage later today. Here's the last task if you choose to accept it. For everyone that took precious time out of their day to be here, what I'd ask in closing is for each of you to describe something that our audience here can take back to their jobs, their responsibilities, and apply right away to help address some form of risk that they're likely contending with in their jobs with their responsibilities. Is that clear? Sorry if that wasn't clearly stated, but just a little bit of that wisdom so someone walking out of this room knows what they can do tomorrow or next week.
Thanks for passing me the mic.
You're welcome.
So who wants to go first?
Larry.
I haven't had to grab it once. You passed it to me every time. It's great. I would just say some of the stuff I said before. Go to your plant and look for some of the simple things like we talked about here today, like the password stuck to the screen. like the unlocked cabinets, like the basic procedural work process kind of stuff that might be going on in your plant or not going on in your plant, that might create vulnerabilities. It doesn't matter what area of technology I'm talking about, that's usually my go-to response. There's probably some things you can do right away, right now, in your plant that aren't going to cost you any money. They're going to cost you some time. It might cost you aggravation on the part of your employees if you ask them to start doing things a little differently. But to me, it's always been one of the key problems in our industry is that we adapt to new technologies and we latch onto new technologies, but we don't change the way that we work in our plants. And that just doesn't work. You have to change the way that you work and really focus on basics, and that's not a huge investment.
That's good. Larry, should we have them score each of these answers?
Yeah, scorecards.
Yes,
That'd
no?
be fantastic.
That's good. Thank you. Go ahead, Marty.
I'm going to disagree with Larry, just for fun. Although I agree with the concepts, right? It's kind of like similar to this whole cyber hygiene type concept, right? Which I guess means there are some things that you should do well everywhere, like locked cabinets and patch levels or whatever. And my advice, I guess, would be find your crown jewels. Find that system or small set of systems that are absolutely imperative to whatever your business is, right? And this could be some ancillary system that you haven't even thought about, right? It's not one of your most complex safety systems. It's just some piece of technology somewhere that is so vital that if you lose it, really bad things happen. And then do a risk assessment of it, evaluate, well, can bad things be triggered to happen through cyber? And then start closing that gap and building some layers of protection around that system. I think I've been guilty in the past of this sort of, well, you have to do it across the board for all systems. And that's not very good advice for a human resource constrained workforce, right? So find those one or two systems that are really critical and start working on those. And once you've got those under control, go out another ring, right? And start nibbling away at the problem.
Oh, you're making it not completely easy to add something fruitful to what you just said. But nevertheless, let me give it a try. I think the most important from my point of view is, first of all, understand what is your inventory and understand what are the boundaries. It means what we see in our practical experiences quite often is that people are not having real awareness of what is existing in their installations and what is the nesting between the different components. And from our point of view, of course, it's important to protect your crown jewelries, but first of all, you need to identify what else is in your basket. Because at the end of the day, somehow you want to get all the eggs in your basket protected. And based on that, you first of all may need to understand what is in your basket.
For me, it would be remote access, whether it's a vendor or even somebody within your company that has the ability to connect into those systems is cut the wire today and find a way to manage that access into those systems so that you know who it is, why they're in them, when they're in it. And then just as a caveat, the training piece, again, don't wait till the day that you need to respond. Start running your people through some tabletop exercises, even just to get it in their mind of, hey, who do we call if we see something that doesn't look right? And to get them, thinking in that manner. Similar to offshore, how we run through, we do a fire drill every week, a man overboard drill. We're launching lifeboats on a timed basis for that, to maintain that training and exposure into that. So if you can do that from the cyber side is also critical.
Yeah, so I would say that regarding your SIS systems, Again, some of the newer systems, they don't even have a key switch on the logic solver. They're highly distributed. There's just a lot of them, and there's no key switch. But they come with a software lock mechanism. And so, understand your system, and then are you using segregation of duties to manage changes to that logic solver? For example, trip set points and basic configuration changes. Are does a supervisor unlock it and then an engineer do the download, for example? Are you using segregation of duties around that? And then also take in consideration that there's instrumentation attached to the logic solver. And so there's often different systems that manage your instrumentation. And are you managing access controls around that interface, your instrument asset management system? Are you managing the access controls around that, again, using the principle of least privilege, make sure that only the people who need the access to make those kind of changes actually have the rights.
All right, I have one last question for all of you. This is kind of a test. A show of hands for who rates safety more important than security. That is not everybody. Can we go the other way? Security more important than safety? You know what the third choice is, right? They're both equal. Show of hands on that. Anybody change your answer when I added the third one? No? All right, awesome. Well, I want to thank our panel for all the wisdom, expertise that they've brought us. So please join me in giving them a round of applause.